Hello again. My name is Dr. Phil Stokes. I'm the Executive Director of Penn Dixie Fossil Park and Nature Reserve in Hamburg. Today, I'm not at Hamburg. I'm actually quarantining at the lovely Graycliff on the shores of Lake Erie. You can see behind me the beautiful water. We're up here on a cliff, and I'm going to tell you a little bit about the fossils and geology and how that ties into the history of the estate. All right, I'm up here on the balcony in the back of Graycliff, the second story. Directly behind me is this really marvelous feature known as the Chimney Stack. The Chimney Stack is made up of large limestone blocks. That's sort of the mottled gray color you see, with cement in between. And then you notice this very, very contrasting dark red iron oxide staining. We'll take a closer look at that in a minute. I wanted to tell you about this really neat feature that's behind me. This window was actually not part of the original design. It was changed during construction per the suggestions of Isabel Martin. The story goes this space behind here was supposed to be a closet, but was transformed into a bathroom, and Isabel wanted a window to look out onto Lake Erie. And so during construction, the limestone blocks were cut so that this window could be put in place. And then the closet was moved into a different location. Now, also behind me, you may notice some interesting markings, letters and numbers on the limestone blocks. They're kind of everywhere. These markings were put in place by contractors. And during a restoration effort here at Graycliff, the goal was to disassemble the chimney stack and then reassemble it and be able to put all of the limestone blocks back into the original locations. So these markings help the contractors know where the blocks came from and where they needed to go during reconstruction. Now, what's fascinating about these limestone blocks is you can actually spot fossils within the limestone. This limestone is locally sourced. The building materials here are from the area around it, and this is considered organic architecture because of that design feature. Now, in this limestone block, which I suspect is the Tichenor limestone local unit, limestones are sedimentary rocks. They're deposited in shallow marine water, so this would be ocean water, and they typically form in coral reef type environments where the water's circulating very well. There's a lot of oxygen, a lot of animals alive that are filtering the seawater and then excreting calcium carbonate. That calcium carbonate, which is their waste product, essentially forms the limestone. And on top of it, not only do the animals waste, does their waste create the rocks, but when the animals die, the exoskeleton of the animal becomes incorporated in the matrix of the rock itself. So you can see here by my finger, there's a really interesting pattern. This pattern is a fossil known as a tabulate coral. Now, tabulate corals are extinct now. You won't see any more of them. But really, there's some similar corals today. And in fact, most of the corals that I know of are colonial in the sense that there are many, many organisms living together, communal style. So tabulate corals were very similar to some modern corals. And this particular one, I believe, would be called Favicites, which is a common tabulate coral from the Devonian period. Because of this pattern that you see here, this sort of honeycomb structure, another name for tabulate corals is honeycomb coral. Now, in the limestone blocks, there's another type of fossil that you can find here at Graycliff. It's a small animal. It looks a lot like a clam, but it's called a brachiopod. Brachiopods are physiologically very different from clams, but they lived around the same time as some earlier clams. Unfortunately for the brachiopods, most of them are extinct today. But back during the Devonian period, when these rocks were deposited, brachiopods were far more common than clams. They were pretty dominant, they were very diverse, and their shells fossilized almost perfectly, and so We know of many species, dozens of brachiopod species that can be found in the local rocks. So there's quite a few to be seen here at Graycliff. There's yet another type of fossil here. This is something that looks like a little disc, or I like to call it the Cheerio fossil. These animals are called crinoids. Crinoid is an echinoderm, which is the group that includes urchins, starfish, or sea stars, and they're still alive today, although the crinoids that are alive now are quite a bit different from the crinoids that lived 380 million years ago, give or take, when this rock was deposited. Now, crinoids have symmetry. In particular, they have five-sided symmetry, and so what that means is that just like a sea star, if you find a crinoid, you should be able to break it down, and you'll be able to see the five sides. Now, this part here, this little disc, is not the full animal. It's just part of the animal, and it's really the middle part. So a crinoid, another name for it is a sea lily. The crinoids kind of looked like flowers. They had a base, they had a stem, and they had a head. Head was known as the calyx, the base was known as the holdfast, and the stem was called the stem. When the crinoids died, the skeleton or the exoskeleton disarticulated, meaning it broke apart into hundreds, if not thousands, of little pieces. And so these discs represent the sections of the stem that were formerly attached together, kind of like vertebrae in the human spine. But now you find them pretty much scattered throughout rocks since they broke down and they were deposited in an incomplete fashion. So if you're looking at the limestone here at Graycliff, keep an eye out for these little discs from crinoids. All right, I am inside now in the main house, which is the Isabel R. Martin house. The main room, the living space, and directly behind me is the fireplace. What's neat about this feature is it's actually a double fireplace. So there's one fireplace on this side, and there's another on the other side. It was designed, it's a huge hearth. It's absolutely massive. And considering this is a summer home for the Martin family, there's questions about how much it was used. But it's an absolutely massive feature, and it has some unique stones in it that you don't see upstairs on the balcony. So we're taking a closer look at the fireplace here. Now, directly behind me are some rocks that are very different from the ones you see outside, or even just down a little bit lower at floor level. This, I think, was deliberate placement here of these rocks because they're so unique. You'll notice there's a lot of different colors and textures. The limestone, if you remember, is kind of like that mottled gray with some iron staining. Indoors here, though, there's pink. There's, I'd almost call this maybe like a black with some sort of green beige highlights. And you kind of have the sugary texture on this rock. This is a black and white with a shiny crystalline texture that you can see. And then you have this sort of rounded, buff-colored stone top center. And there's quite a lot of variety here. So where did these rocks come from, and why are they in western New York? If you can't recognize the texture here from your earth science Regents high school earth science tables, these are igneous and metamorphic rocks. So if you remember your three rock types, you've got sedimentary, igneous, and metamorphic. Sedimentary rocks form in water through deposition of sediments or through precipitation of calcium carbonate, like in limestone. Igneous rocks are formed from magma, so liquid rock that has cooled. And then metamorphic rocks form through application of heat and pressure on a pre-existing rock. So what's neat about what's behind me is you get sort of the gamut of rock types. I think this buff-colored rock, I strongly suspect it's a sandstone. The only way to know for sure would be to break off a little piece, and I feel like that would not be welcome here at Graycliff. This large rock behind me, you can see the texture here has sort of like a pink matrix with like white or clear little crystals, and then these black larger crystals. This would be granite. So the constituents on granite are feldspar, quartz, and mica, sometimes with other trace minerals. And then the rocks next to it are really interesting. So these were probably igneous rocks to begin with, but now you can see this banding in here. These rocks have been metamorphosed. So they were igneous rocks that were then compressed with tectonic forces. So not a bulldozer, but something many, many, many times more powerful. Basically one continent colliding into another continent. And then this rock down here has some shiny black minerals in it. That's a mineral called biotite mica. Biotite mica is common in certain igneous and metamorphic rocks. And then this one right here is mostly kind of the light pink color. This one, I believe, is a metamorphic rock called quartzite. Quartzite is basically the end product. When you start with a rock like sandstone, you heat it up, you put it under pressure. The sand grains, which are made of the mineral quartz, partially recrystallize, and so they create this very sugary texture that you can see. And then, of course, for decorative effect, there's a brachiopod fossil stuck in the matrix here between these igneous rocks. So the rocks of western New York are sedimentary, nearly all of them, with a few exceptions of things in the Finger Lakes that are, it's a whole other story, a rock called kimberlite. But pretty much every rock in western New York is sedimentary. So where do these igneous rocks come from if they weren't imported here by the builders? And the answer is something you're very familiar with if you're from western New York. It's snow and ice. So approximately 20,000 years ago, there was a glacier in western New York. The time was known as the last glacial maximum, or the end of the most recent ice age. There have been dozens of ice ages, but the most recent one ended about 20,000 years ago. And at the time, there was ice here in western New York. It was somewhere between 1 and 2 miles thick. Now that's a lot of ice, and the ice was coming from northern Canada. So essentially the polar regions were pushing this ice south, and the ice terminated around Salamanca, New York. So somewhere north of Buffalo, probably north of Toronto, is the likely origin of these igneous and metamorphic rocks, which were formed way, way, way before any of the rocks in western New York were deposited. These rocks are from most likely from the Canadian Shield, which is a geological feature that dates between 2.5 and 4 billion years ago. So we were looking at rocks upstairs that were a few 100 million years old. These rocks are billions of years old, so they're substantially older. So what happened was they formed in Canada. They were essentially sitting there for a very long time, and the environment was relatively stable. And then these glaciers came along, and much like bulldozers, the miles of ice pushed the rocks south across Ontario and across these basins that we have here. They're the Great Lakes now, but at the time they were just being carved out by ice. So the glaciers bulldozed the material south, and they brought it to western New York. Now, Graycliff isn't the only place that you can find boulders that have been transported by glaciers. In fact, if you're out in the region, if you're out in streams or parks, or along the Niagara River even, you might find some of these boulders. And the thing to look for would be shiny crystals, and this metamorphic or igneous texture that I've pointed out here gives you a very strong clue that the rocks are not from around here. Well, here I am again, outside of lovely Graycliff on the shores of Lake Erie. Graycliff and Penn Dixie both are currently delaying our reopenings due to the health crisis. We wish we could be open for you to come out and explore. Unfortunately, the virus situation has really made it difficult for many small nonprofits such as Graycliff and Penn Dixie. But let me tell you, we are here for you once the situation improves. Once businesses can reopen, we'll be ready. Graycliff, you can support them at experiencegraycliff.org. You can support Penn Dixie at penndixie.org. And on behalf of the staff of both organizations, thank you so much for watching, and we hope to see you very soon. Stay safe.